Lesson 2, Video 3, Number 14. The given functions are sketched on the coordinate plane shown. We label each function. So the greater the b value, the steeper the curve. So the steepest curve I see is right here. So I would call this one g of x, because that's 3 to the x and it's the steepest curve. The next steepest curve is right here. So that would be f of x, which is 2 to the x. The next steepest curve is way less steep, that blue one there, so that would be k of x, which equals 1.3 to the third. And then the only graph that is decreasing the entire time is this one over here. So that must be j of x, because the b value of 3/5 would be equivalent to 0.6. And 0.6 is in between 0 and 1. So that's how you know that it would be a decay graph instead of a growth graph like the other three. For part B, consider the function m of x equals e to the x. Use your knowledge of the approximate value of e to sketch and label its graph on the coordinate plane to the right. So if I scroll back in that highlighted part, e is approximately 2.7. So 2.7 is in between 2 and 3, but closer to 3. So when I draw in this new graph, I want to draw in a curve that's in between g of x and f of x, but closer to g of x. Obviously, it's very hard to make this super accurate. Just do the best you can. So I'll go in right. Oh no, Notability is giving me a straight line when I want a curved line. Let me see if I can undo that. I'll start down here at the y-intercept. Just kind of curve this up. And then curve it in between the yellow and the green. So obviously not the best graph in the world, but you kind of get the gist of it. And I'm going to label that m of x. So again, that's in between 2 to the x and 3 to the x. And I wanted to make it closer to 3 to the x, but my graph's a little bit off. For part C, using the functions f of x equals 2 to the x, g of x equals 3 to the x, and m of x equals e to the x, approximate the values of f of 2, g of 2, and m of 2. So a couple ways you could do this. On your graph, you could go over to when x is 2 and just slide your eyes up the graph. Or what I feel like is almost easier, just take x and plug it into the actual equation. So f of 2 is 2 to the second, which is just 4. G of 2 equals 3 to the second, which is just 9. And then pink. M of 2 is approximately 2.7 to the second. So if I grab a calculator, 2.7 to the second is about 7.29. So I'll just say about 7. And again, I just did that plugging into the calculator. And if I was looking at my graph, I could get those same values approximately. For 15, we want to sketch the graph of f of x equals 1/5 to the x and identify the characteristics listed. Make a table if you need to. I would definitely recommend making a table. Let's actually do that. So off to the side here, I'm just going to do an x, y table. And I want to do a couple x values on the left and a couple x values on the right. So I'll start with -2. So if I'm raising 1/5 up to the -2 power, I'll do that way off to the right here where I have a little bit of space. If I go 1/5 to the -2, remember that negative sign makes me flip the fraction over. So essentially this would be, it would turn into 5 squared over 1 squared, which is just 25. Again, that's because the -2 gets applied to the numerator and the denominator, but then you have to flip it because it was a -2 instead of a +2. Once you do the flip of the fraction, the exponents become positive. So instead of 5 to the -2, it's 5 to the +2. So that's going to be 25. So if I do 1/5 to the -1, that flips it over, and it becomes just 5. Anything to the 0 power is 1. 1/5 raised to the first power is just going to be 1/5. And then 1/5 squared should be 1 over 25. So as I'm plotting, -2, 25 will be way up here, even farther up there, but I kind of run out of space on the graph. -1, 5 would be about there-ish. 0, 1, 1, 1/5, 2, 1 over 25. So the graph would look something like this. Notice how it is a decay graph. This happens because 1/5 is in between 0 and 1. So if our b value is in between 0 and 1, it's a decay graph, and it is decreasing the whole time. So for our domain, just -infinity to +infinity. So those are all your x values. Everything works for the x values. For the range, we don't go below the x-axis at all. So 0, infinity. For the asymptotes, we never cross the x-axis, so y equals 0. For our intercepts, we saw over here in our table 0, 1 for a y-intercept. And behavior, as x approaches infinity, f of x approaches, so I'm looking right here. As x is getting bigger and bigger and bigger, what is this pink curve doing? Why, it's getting closer and closer and closer to 0. As x approaches -infinity, so over here on this end, as x is getting smaller and smaller and smaller, that pink graph is going up and up and up and up. So our y values, our f of x values, are approaching infinity. And then that last one, it's an interval of decrease because it's decreasing the entire time, and it decreases across the entire domain. So -infinity, infinity. 16. Caleb wants to invest $1,000 in a savings account. Washington National Bank is offering 5.5% interest compounded continuously. So there's that word continuously. That's what tips us off to the fact that we should be using that A equals principal times E raised up to the RT equation. So for the function, we have A of T equals our principal, our starting amount, $1,000, times E to the rate times time. Remember, when we have that percent, we need to write it as a decimal. So we need to move the decimal point 2 places to the left. And that was from the 5.5% interest. And that should be it for part A. Pause the video and try part B. And while you're at it, why don't you try number 17 as well? So pause the video, finish 16, and try all of 17. Now that you have tried the rest of the problems, let me have you check them. So I'm going to plug in 6 for T in part B because it says after 6 years. So I'm just going to plug in 6. And then when I plug that in, I get about $1,390.97. And then on 17, we have a starting year of 2010. Here's our starting population, and then our rate is 1.8. So written as a decimal, that's 0.018. So we can still start with that same function where we do our starting value. and then times e raised to the rate times time. And again, it's the rate written as a decimal. So that's all they're looking for part A. And then for part B, since we're talking about the year 2030, to go from 2010 to 2030, I'm just subtracting over here off to the side because I saw a lot of you struggling with this on the first formative. From 2010 to 2030, that's 20 years. So when you're using the formula, you're going to let t equal 20. And then you just type it in to the formula or plug it into the formula. It's very easy to mess up the number of zeros on this. So we have, I think I did that right. Yes. And then e times 0.018 times 20. So there's your initial equation. Type it in. I get 2,149,994. So 2,149,994 people. And since we were talking about people, I just rounded to the nearest whole number, since we're not going to talk about 0.3 of a person.